Rightio, this is a very quick look at logs from page 87. If you can remember this, 2 to the power of 4 equals 16. And the equivalent statement in logs is log base 2 of 16 is 4. Okay?
Is that log of 2 16? How do you say that?
Log base 2 of 16 is 4.
I thought it was always a base. I don't get the base thing. You say
Well, okay, see this 2 to the 4 equals 16. Yeah. The base is 2, isn't it?
Right. But we always work with base 10.
No, we don't. We work with all sorts of things.
He said base 10 because
Well, we live in a world of base 10, you know. Metric system is based on base 10, isn't it?
he said in the sixth form they were only using base 10 for example.
Okay. Right, Homer will have to be set free. So, because that's just absolute nonsense. We use the base 10 on our calculator all the time because we haven't got any choice. Okay. I'd say it to his face. If he came in right now, I'd say, you are wrong. Now, this is going. I wouldn't. No, that's over the top. But I'm not going to repeat what you said. Now, so if you're happy with this, the top one, which 2 to the 4 equals 16, very simple year 10 thing. Then down here, the log equivalent statement is log base 2 of 16 is what? 4, of course, because that's the power. So log gives you the power. So if you get a question like, find the value of q in each of these statements, log 5q equals 2. Here's question number 3, and I want you to do some of these. I'm just going to do the odd one. Log base 5 of q equals 2. How do we do this? Now the short answer is you don't try to get your head around, or I don't think this is a good idea, is to sort of read logs like you read powers. I think most of us can fully understand 2 to the 4 equals 16, it's just almost just straight up without any thought, any effort. 2 to the 4, 16 makes complete sense. But log 2, 16 equals 4 takes a bit of effort. So what I want you to do is when you get a question which says a log question, which says work out something and there's logs in there, just convert the whole lot into an index equation because we know how to do that. This says log 5q equals 2. The base is 5. So the equivalent statement is base is 5. What's the power? 2 equals q. That's not very hard. What's q? 25. So by converting it into an index statement, it takes something which looks a little bit confusing. And I've done this for a long, long time, and I still mentally convert it into index form. Okay? Because it just is easier that way around. So I've converted it into this, and q equals 5 squared, q equals 25. That's not very hard at all. Okay? Now, if we look at the next one, number 4, we'll do part C there. Log 16x, is that the same? Yeah, it's exactly the same, so we'll skip those. Let's try number 5. 5 part C says log base p 9 equals 2. So question 5, log base p of 9 equals 2. Log base p9 equals 2. Now, what we're going to do is we'll rewrite this in index form, just like we did the other one. This means p squared equals 9. Clearly, p is what? And we have to be careful, because can p be negative 3 as well? Can we have a base of a negative number? Answer, I would say yes, we can. Negative 3. Yeah, well, we have to have both. No, because we can get situations where we get negative 3 squared equals. That needs to have an equivalent in log form as well. So therefore the base is a negative number. That's okay. So the base can be both. So we get both positive and negative 3 for that question. Have a look at number 6 is the same. I'm just looking down the list, and let's have a look at
6G.
Yeah, 6G. Go for one which is a bit more cunning. Log P of. Let's do 6G. And this one says log P 1 over 25 log base P 1 over 25 equals -2. Now, right, so we do our conversion. We turn this into P to the power of -2 is 1 over 25. Well, we've lost the log. We've turned the log into an index. That's the whole point of transferring it into the index form. We lose the logs which we're unfamiliar with, and we go into a format that we're familiar with. Now, what's P to the -2 the same as? What's P to the negative anything mean? Neither of those? Not that either. So we've gone for, yeah, I'm not even going to say them out loud. What is x to the -3 is exactly the same as that. Can't be the same as x to the 3, can it? They'd be x to the -3, x to the 3 are different things. So x to the -3, the negative means 1 over. It means it lives on the bottom line of the fraction. X to the -3 is 1 over x cubed. So what does P to the -2 mean? One over p squared is the correct answer. So if that's 1 over p squared, and that's 1 over 25,
How come the sign changes to positive square?
because the negative doesn't really stand for a negative. It's not like negative, a negative number or a positive number. The negative means that thing, p to the -2, actually means 1 over p squared. That's what it means. The negative refers to the p squared being on the bottom line of the fraction. Okay? P to the -2 is 1 over p squared. So if you compare 1 over p squared with 1 over 25, what must p be? P must be 5 or -5, exactly. So looking at this, just comparing those two fractions, p has to be 5 or -5. Yeah, therefore p equals plus or minus 5. Okay, which going back to our original question here, log p 1 over 25, log of 5, log base 5 of 1 over 25 is -2. It has to be, because if you think about it, 5 to the -2, p to the -2, 5 to the -2 means 1 over 5 squared, which is 1 over 25, which is that there. Okay, so those ones, number 6, drag in the fact that you've got to know about your negative index rules, which is sort of the last couple that you get at year 11. Okay, so that's sort of that's about it. And you don't get a hell of a lot of this in your algebra test. You're going to get a lot more of the properties of log stuff, which is sort of the next section. This is just fundamental laws of logs and how a log equation, like how does this is part of your algebra topic. Remember, algebra is 4 credits, big test, big external test, and this is part of algebra. What's that? Oh no, that was the cat. That was the yeah. No, you're allowed in standard calculator. So basically, what this exercise here is doing, and we'll do these today, and I'd like to be able to show you the properties of log stuff tomorrow, but Homer will probably do that. This log 5q thing here, log base 5q equals 2. If you can easily convert backwards and forwards here, then you're in business, because solving an index equation is straightforward because it's familiar. Converting away from the log is definitely the first step. So what I want us to do is do a couple from each of three. This is the right-hand column of 3, 4, 5, 6. So if you have a look down page 87, 3, 4, 5, and 6. And if you just look at the right-hand column, then that's the B, D, F, and H column there. If you just do 2 from each, starting now would be good. Okay, start at 3, do 2, do them exactly like I've done these. Oh, I don't know about that.